Welcome back, everyone. I am super excited to be your guide for today's explainer brought to you by Forge College. Okay, so I know you all just wrapped up what was likely a brain-melting session on planning and integrating your Rust modules. So seriously, give yourselves a massive pat on the back for that. But it is time to shift gears. Today's mission, we are drafting a rock-solid concrete blueprint for your HelloWorld contract. And we're going to do this before we even think about writing a single line of Solidity code. Look, we all know the temptation, right? Your coffee's hot, the editor's open, and you just want to mash the keyboard and see things compile. I completely get it. But building smart contracts on the fly? Yeah, that is a one-way ticket to a big, messy bowl of spaghetti code, and potentially a drained treasury. A true Web3 engineer drafts a blueprint first. Trust me, it saves us from endless refactoring and agonizing gas headaches down the line. So here's our blueprint for today. First, we'll look at the microservice mental model. Then, the smart contract file layout. After that, we'll go through your deployment checklist. Fourth, we'll actually design HelloWorld as a concrete example. And finally, we'll wrap up with your next steps. Let's dive into part 1, the microservice mental model. Here is the absolute secret to great architecture. Treat your contract like a single responsibility microservice. Basically, in this model, your state variables aren't just random data sitting around. They act as your persistent database. Your public and external functions, well, those are your highly focused API endpoints. And your events are explicit logging hooks for the outside world. It's a beautifully clean, modular mindset that really just cures the chaos. This perfectly illustrates the difference in developer mindsets. Over on the left, we've got the chaotic, amateur approach, treating a contract like a loose bag of functions. Everything is tangled, state variables get updated randomly, and there's absolutely zero clear boundary of responsibility. But on the right, we have our goal. A sleek, cohesive microservice. Every single responsibility is intentionally mapped to specific state variables, dedicated functions, and clear event elements. It completely brings order to the whole system. Adopting this mindset forces you to make minimal, testable design decisions. Instead of adding bloated features just because you think you might need them later, you map exact responsibilities. What needs to be saved forever? That is your persistent state. How do people interact with it? That's your public API. How do off-chain apps know what happened? Your event stream. And what happens when things go wrong? That'll be your error handling. Doing this keeps your contract lean, cheap to deploy, and honestly, infinitely easier to audit. Moving right along to part 2, smart contract file layout. Think of your Solidity file exactly like zoning a building. You want a linear, totally predictable floor plan. At the very top, we have our header for legal metadata, like the SPDX license. Next, imports bring in outside materials, think Open Zeppelin libraries. Then, before the core logic, we declare errors and events. After that, the contract block opens with state variables, followed by public API endpoints, and finally, tucked away at the very bottom, are internal helpers. Now here is a massive pro tip for your layout. Place your events and custom errors early in the file. Honestly, this does a huge favor for anyone reviewing your code. It lets readers and off-chain apps instantly understand how your contract communicates externally. It's exactly like putting the menu on the window of a restaurant. People know exactly what they can order without having to barge into the kitchen. All right, part 3, your deployment checklist. Let's run through the first 3 steps of our lightweight 6-item checklist. Step 1, explicitly confirm your pragma and compiler version. Pin it down, do not leave it floating, otherwise you are risking accidental breaking upgrades. Step 2, validate your SPDX license and make sure your NatSpec comments, those helpful developer notes, are properly formatting your API. And step 3, which is absolutely critical, verify your event schema stability. You really have to lock in your event names and indexed fields right now, because if you blindly change them later, you will catastrophically break every single off-chain consumer, dashboard, and indexer relying on your contract. No joke. Finishing up our safety check. Step 4 requires unit tests with event assertions, so actually check the logs, not just the state. Step 5, estimate gas for your state-changing functions. Do a dry run locally unless you really enjoy the surprise of donating your life savings to mainnet validators. And step 6, prepare your deployment parameters so you know exactly which address will be the initializing owner. Let's jump into part 4, designing HelloWorld, our concrete example. We're going to start with our single responsibility statement. Store a canonical greeting string, allow authorized updates, and emit concise events when the greeting changes. That is it. That's the whole shebang. That is our ultimate guiding principle. If a feature doesn't serve this exact sentence, it literally does not go into the contract. This strict engineering discipline is exactly how we prevent feature creep and keep our microservice laser-focused. From that simple statement, we can derive our exact state variables. First, a string named greeting. This will be our persistent on-chain message. Second, an address named owner. We need this for simple access control. We want to restrict our setter function to just the owner, mostly to avoid spammy, chaotic updates in our demo environment. And third, a uint256 named version. This is just a handy optional variable to allow for simple on-chain schema bumping if we ever upgrade things in the future. Next up, we design our event schema. Here we have greeting changed, which takes an indexed author and a new greeting string. Notice the intentional design choice here. We index the author address. Why? Well, so off-chain applications can efficiently filter and search for updates made by specific people. But we deliberately leave the actual greeting string unindexed. Indexing a string creates a hash, which makes it harder to read directly and, frankly, costs more gas. Keeping it unindexed keeps our logs compact, readable, and highly efficient. Finally, we lay out the informal signatures for our API endpoints. We have greet, which is an external view function. This is strictly read-only, meaning it costs absolutely zero gas to call from off-chain, and it just returns our current string. Then we have setGreeting, an external function that will validate the caller as the owner, update the state, and emit our greeting changed event. By writing these signatures down right now, we have the exact specifications we'll bring to life in our unit tests during our next coding session. I know you're itching to code, and having this blueprint is what makes that process perfectly smooth. And that brings us to part 5, wrapping up and next steps. So, what is the big takeaway from today? Your goal is to produce a single artifact, a structured one-page design outline. It needs to contain your mapped state and functions, your locked-in stable event schemas, and your 6-item deployment checklist. Listen, this isn't just busy work. This one-page outline is the exact document we're going to use, line for line, in our next lesson titled Building the Contract Skeleton. You won't have to think about design then, you will just be executing your master plan. As we wrap up, I want to leave you pondering this. How will the exact wording of your event schema dictate your off-chain reality? Think about it. What you design in total isolation on-chain becomes the absolute truth that every dashboard and indexer out there has to live with. Thank you so much for joining me for this explainer created by Forge College. To dive deeper into this subject and explore a whole bunch of other Web3 topics, definitely head over to forge.college. Keep your lines straight and your blueprints clean, and I'll see you in the next one.